Hello everyone, welcome back to Electro Study YouTube channel. In this session, I am going to discuss important question related to network analysis which can be used for all circuit branches. The topic to be covered in this session, number one, KVL and KCL, transient response of DC network, resonance, filters, ideal voltage and current. These are the topics to be covered. So I just wanted to have a brief discussion only because it's a short video. So let's understand some important point related to above topics. So first one, we'll understand what is the importance of KVL and KCL. Okay, we can have a look on KVL and KCL. So first point I want to discuss, point number one, we can note down individual points. Okay, so KVL. KVL, you know, what is KVL? The algebraic sum of product of current and resistance and EMF acting on the circuit, that is equal to 0. So product of current and resistance is nothing but voltage drop. Sigma voltage drop, right? Sigma voltage drop and EMF in a closed loop, that is equal to 0. The KVL operates based on the conservation of energy in a closed loop. That is one of the remarkable point. Likewise, there is another terminology called Kirchhoff's current law. So, algebraic sum of current meeting at a junction or a node equal to 0. Sigma I equal to 0, you can write it. By the way, the KCL implies conservation of charge. Okay, you have to remember these 2 points. Third one is the transient response of DC circuit. Transient response. Transient response. Some equations you are to familiar and some basic concept. So please read any of the textbook and appear. So I just wanted to give the shortcuts. Number one, for RL circuit, consider an RL circuit. Okay, you have to consider RL circuit provided with the DC supply. Now, see the inductor. What is the speciality of inductor? In case of inductor, it opposes the change in current. That is one of the important points. Also, inductor is an energy storage device. And the inductor stores magnetic field, energy in the form of magnetic field. That is another point. So the total energy which is stored in the inductor is equal to half Li square. Also, the equation of current at the time of charging, you can write, okay, charge equation of current, that can be written as Vs by R into 1 minus e to the power minus R by L into T, where R by L is known as time constant for RL circuit. Okay, R by L. Sorry. The time constant tau can be written as L by R. This is very important. Okay, please note down this. Time constant is equal to L by R. Please delete the previous one. Yeah. I think it's clear to everyone. This point you are supposed to note down. And also, what is the tau? Definition of tau? Definition of tau, that is nothing but time taken for a variable or a signal to reach, this is very important, 63.2% of its final value. 63.2% of its final value. I have seen these kind of questions in many question papers. This is very important, kindly note down. Okay, that is the importance of tau, time constant. Time taken for a variable or a signal to reach 63.2% of its final value. So that is regarding the current for an RL circuit. It's a rising current. So this is happening whenever the on condition, whenever the switch is on condition. Okay, switch is on. Switch is on condition. Suppose if the switch is off condition, when the switch is off, what is going to happen? That means the decay of current will be taken place. Whatever the energy which is stored, that will be discharged. Or at the same time, we can explain in terms of current also. Current is also coming down. Okay, so the decaying current can be written as Vs by R into e to the power minus R by L into T. So this is a simple behavior of RL circuit which is connected to a DC supply. RL. Okay. So I have explained the two conditions, on condition and off condition. So what about the behavior of current? What is going to happen for the current? Okay. So in case of inductor, we need to concentrate the changes in current that we are supposed to consider. Okay. Current through the inductor. I think you are understanding. Okay. Here, in case of off condition, how to define the tau? Tau will be same only, L by R. Here the definition, you can note down the definition. In case of off condition, decaying current. In case of off condition, there is a decay. The current decay will be taken place. So the time tau by which current falls in 36.8%. Current falls in 36.8% of the final value. That is called time constant in case of off condition. This is regarding time constant in case of on condition. So separately you have to bifurcate it. Okay, this is actually the total time in case of on condition. The current 63.2% of the current that reaches to final value. That is a time constant. But when it comes to off condition, it is almost 36.8% of the lower value or falling time. So that is the time constant. I think it's clear to everyone. Now let us talk about the RC circuit. So 3 points we have discussed. A lot of informations are there. So for details, you can refer any of the network theory textbook. Okay. So brush up the details. Then you can see this video. Then you can understand the concept very clearly because it's a short video. I can't elaborate further. Anyway, I am planning for lecture series on network analysis. At that time, I will be taking my own time. But this is only for competitive examination. Then fourth point. So we have to talk about RC network, RC circuit supplied to DC. Okay, here also you have to explain on and off condition. On and off condition. So you know RC circuit, right? Anyway, when it comes to capacitor, so we need to focus on the voltage. Understood? No. In case of inductor, we have to speak about current. Current is a variable. Here, voltage is a variable. So the capacitor prevent changes in voltage. That point you have to note down. Okay. So that is regarding RC network. So in case of RC network, so we need to say that the energy stored in the capacitor energy is going to store inside the capacitor. Okay. So that is given by energy is equal to half CV square. Okay, you must have studied in +2 classes. That's why I'm not noting down again. But we have to speak about the behavior of voltage during on condition and off condition. When the switch is on condition, what about the behavior of the voltage across capacitor? So voltage across capacitor that can be given by Vs. Vs is the input voltage 1 minus e to the power minus 1 by RC into T plus. Okay, you can copy V0 into e to the power minus 1 by RC into T. Okay, so this is regarding the voltage during on condition. Here we can say that tau is equal to R into C. This is a time constant during on condition. Likewise, in off condition, we can able to write Vc of T that is equal to Vs into e to the power minus 1 by RC into T. So this is what exactly happening during off condition. Here, what is time constant? That is tau is equal to RC. Both the condition we can write tau is equal to RC only, but the values will be different. So this is actually happening during charging. capacitor is going to charge, and this is happening when the capacitor is discharging, correct? Discharge. The energy that is equal to half CV square. So energy stored from the electric field. That is a specialty in case of capacitor. But in case of inductor, energy is stored in magnetic field, in the form of magnetic field. Here, energy is stored in the form of electric field. So that's the difference between inductor and capacitor when it comes to a DC supply. I think it's clear to all. So note down this important equation. Note down what is time constant and what's happening during on condition, what's happening during off condition. If you want, you can draw a simple circuit also, but I haven't drawn. These points are valuable for your exam point of view. You have to remember any cost. Derivation is not required. Okay, no derivation required. Only these equations. Next one, I just wanted to discuss about resonance condition. So what is resonance? So you must have tuned your radio, correct? So you have experience in that. So what is the resonance? Resonance is nothing but the inductive reactance. In an RLC circuit, if the inductive reactance is equal to the capacitive reactance, the resonance condition occurs. Also, impedance offered by the circuit become pure resistance. In case of resonance circuit, we can write the overall impedance is equal to the whole resistance. That is an important point. Similarly, voltage across inductor and the capacitor phase shifted by 180 degree. That is another remarkable point. So you can calculate the resonance frequency. So you can write FR or F naught, whatever it can be, 1 by 2 pi into root of LC. This is very important equation. Similarly, another important thing is called quality factor, Q factor. Quality factor. You need to calculate quality factor in some problems. So here the quality factor you can calculate. Q is equal to 1 by R into square root of L by C. This is a formula for calculating the quality factor. Similarly, there is a relation between quality factor and the bandwidth. So what are the relation? So in case of RLC resonance circuit or network, we can write the quality factor. Quality factor is equal to the frequency divided by bandwidth. Here, the quality factor is inversely proportional to bandwidth. This point you have to note down. Okay. So these are the important points. So far, we have discussed about KVL, KCL, then RL with DC, RC with DC. We studied about time constants. Also, we discussed one of the phenomenon called resonance. So based on the preliminary knowledge and some important equation, you can easily solve the five questions. I am going to put up 5 questions for you. Kindly evaluate by yourself first. Later, we'll discuss. Let me know how much score you are getting out of 5. You can have a self-evaluation. So if you want, you can pause the video and put up the answer. Okay. Any queries you can put up in comment box. It's mostly welcome. Interactions are required. Yes. Moving on to the discussion. The first question. So the transient current are associated with. Can you find out the right answer? Yes, the transient current. We have discussed about the transient current. That is I of t at on condition and off condition. Here, the transient currents are associated with the changes in the stored energy of inductor and the capacitor, because both are energy storage devices. Correct, no? So inductor stores energy from the magnetic field, where capacitor stores energy from the electric field. So kindly select option D. Okay, without any queries, you can put up the D is the right answer. Another important question: the time constants of RC and RL network. RC and RL network are or is respectively. Find out. So for RC network, what is the time constant? Obviously R into C. Okay. What about RL network? It will be L by R. So you can go for option B. I think it's clear to everyone. Power factor at resonance in RLC circuit. So you know that the resonance condition, in case of resonance condition, Z is equal to R. The total impedance equal to resistance. That means it becomes pure resistor. In case of pure resistor, the angle between voltage and current, that is equal to 0. What is power factor? Cosine of angle between voltage and current. So cosine of 0, that is equal to 1. So which is the right answer? Unity. 1 is the right answer. A simple question only. You may get it because all the levels of questions will be asking in case of competitive examination. Kirchhoff law is not applicable to nonlinear resistance, lumped parameters, passive elements, distributed parameters. So in case of nonlinear resistance, you can apply KVL, KCL also you can apply. Passive element also no issue. The lumped parameters, that is also possible. But in case of distributed parameters like half line charging admittance, shunt admittance, such cases you cannot apply KVL. Okay, KVL and KCL, both KVL and KCL. So option D is the right answer. Now there is a numerical example. A circuit which resonates at 1 megahertz. So frequency equal to 1 megahertz. It has a Q factor of 100. Quality factor is equal to 100. So bandwidth between half power point is, you have to calculate the bandwidth. How to calculate bandwidth? You already know that quality factor is equal to the frequency divided by bandwidth. Therefore, bandwidth is nothing but frequency by quality factor. What is frequency here? So frequency is nothing but 1 megahertz. 1 into 10 to the power 6 hertz divided by the bandwidth. The bandwidth is 100. 100 means 10 to the power 2, right? So this become how much? This much of hertz. What does it mean? 10 into 10 to the power 3, right? That means 10 kilohertz. So which is the right answer? You can go for 10 kilohertz. So I think concept is clear to everyone. So remaining questions and concept will be discussed in the forthcoming session. Please note that network analysis is applicable for all the circuit branches. It's not specifically for ECE or EEE, not like that. All the circuit branches you can apply the same concept. Any questions you can put up in the comment box. And thank you for listening this video. Let me know if you are having any further queries. We are happy to answer. Thank you so much for watching this video. Have a good day.